let me give you an illustration at this point and show you how you could actually solve for the difference quotient if I give you what the function is. Let's start with a simple example. Suppose we have a simple linear function. Y is a function of x, and this function is just this, 3 plus 2x. Okay. Now, there are two components I'm going to solve for, this term and this term. Given this function, maybe let's actually start with this one, because this one's easier. What is the value of this function at x of 0? What is f evaluated at x of 0? Yes, you just substitute into that equation, put x sub 0 where there's an x. Okay, so this would just be 3 plus 2 times x sub 0. Let's back up a second. What is f of 1? Suppose we let x sub 0 be 1. This is saying what is the value of this function when x equals 1? What is f of 1 going to be? Anybody? 5. Yeah, it's just 3 plus 2 times 1. Okay. Or right here, if we let x sub 0 be 1, 3 plus 2 is 5. Okay. What is f of 0? Going to be 3. Okay. Just substitute in 0 where you see x. Okay. This is f of x sub 0. Just substitute x sub 0 wherever you see an x. Now, this one's a little more tricky, but what is f evaluated at x sub 0 plus delta x? In other words, this is saying what is the value of this function when x is equal to x sub 0 plus delta x? So what do you do to find that? Yes. Ben, was it you? Substitute what? Into what?
X sub 0 plus delta x into wherever you see x.
Right. Exactly right. So we just substitute this value in wherever we see x, so it's 3 plus 2 times x sub 0 plus delta x. Okay. And as Ben did, we could multiply this through. And this is also 3 plus 2x0 plus 2 delta x. Okay. Now, let's solve for the difference quotient. All we have to do now is plug in. If we plug in for f evaluated at x sub 0 plus delta x, it's just this expression right here. 3 plus 2x0 plus 2 delta x minus this, which is just 3 plus 2x sub 0. All divided by delta x. And just let's leave delta x as it is. Okay. Now, notice this numerator simplifies. We've got a 3 minus a 3. So those two cancel. We've got 2x sub 0 here minus 2x sub 0. So all that leaves us with in the numerator is 2 delta x. And that's the denominator's delta x. So you divide through by the delta x, and what do you get? You get a simple number 2. In this case, the difference quotient, delta y over delta x, is just 2. So why does that make sense to you? Why does it make sense that the difference quotient is just a constant 2 in this case? Yeah, the slope of the straight line, the change in y per unit change in x is always 2. So that's just the difference quotient. So in this case, the difference quotient is just the coefficient on x. That is delta y over delta x. That is the change in y per unit change in x. Notice if x increases by 1, how much will y increase by? If x increases by 1, y increases by 2. Okay, delta y over delta x is always 2. So if delta x is 1, this has to be 2 up here. If x increases by 2, y increases by 4. Okay, if x increases by 10, y increases by 20. Always delta y over delta x, that ratio is always 2. So in this case, the average rate of change of y per unit change in x is always 2, which is just the slope of the line. Okay. And you learned in high school, or maybe even earlier, that the slope of the line, just the rise over the run. So if we graph this function, the vertical intercept, by the way, you should always label your axes. The vertical intercept here is 3, and the slope is 2. So it's a straight line that looks like this. Okay. And if you start at a certain point, say this point right here, and you increase x by 1, so your delta x is 1, then your delta y is going to be 2. So this distance here. Okay. Rise over the run. Here's the rise, delta 2. Delta y equals 2. That's the rise. The run is just delta x or 1. The rise over the run is 2. If x were to increase by 2, y would increase by 4. The slope of this line is always 2. It's a straight line. Straight line has a constant slope, has a constant difference quotient. Okay. So that's a simple case. Anytime you have a linear function, the difference quotient is just going to be this coefficient on x.